All right, so now that we have talked through the first, 14 examples, 13, 14, what I'd like you to do now, right, if you are looking at the blank 4.1 notes, if you were looking at the solutions that I've already posted, that's fine, but go away from those now, go to the blank ones, and please, starting on problem 15, 16, 17, 18, oh, I forgot to name this one, 19, right? Please try these on your own and see how you do. So please pause this video now, and after having done the examples from above, use those as a reference and try these out. Pause the video now, and then when you unpause, I will go over the solutions. All right, so for the last bit of class, let's look at and talk through these solutions. So example 15, a 150-degree sector is cut from a circular disc with radius 18 feet. So here's 18 feet is my radius, 150 degrees, well that's 30 more and I'd be at 180, right? So determine the area and perimeter of the sector. So the area, again, is a fraction times the area of your circle. So the fraction is going to be 150 degrees out of 360 degrees total in that circle, times pi r squared. Multiply it out, simplify, you're going to get exactly 135 pi square feet, or approximately 424.115 square feet. The perimeter, again, the arc length is a fraction of the circumference, right? So the perimeter is going to be this arc length S plus 2 radii, right? So the arc length is my fraction times my circumference. So I simplify all that and you just get 15 pi plus 2 times the radius, right? I've got 18 plus 18. So it's 36 plus 15 pi feet exactly, or approximately 83 feet. For number 16, calculate the area of a sector with a central angle given to you in radians and radius 2. So again, your area is your fraction times the area of a circle, right? So the fraction of the circle is pi radians out of 2 pi radians. So when you divide this, right, the pi's will simplify and you're going to have 16 in the denominator, but 2 squared is 4. So your denominator is going to be just 4, right? And we still have a pi. So pi over 4 square inches, or 0.785 square inches. For number 17, let me see, here's my mouse. Number 17, Julia and Ansley leave New York Harbor on different cruise ships. One travels bearing 17 degrees and 37 minutes, and the other 142 degrees and 18 minutes. After both boats have traveled 120 miles, I was so lazy I didn't even change the 120. How far are they apart? So again, practice subtracting, and when you have degrees and minutes, make sure if you borrow, like you can't do this in your calculator. You're going to actually have to borrow a degree and say, hey, that's 60 minutes, so 60 and 18 is 78. Subtract 41 minutes, 124 degrees. So 124 degrees plus 41 minutes is 124 plus 41 over 60 degrees out of 360 degrees. That's the fraction of my arc. That's the fraction of my circle times my circumference, 2 pi r of 120. So about 258.247 miles. So again, very similar to the examples we worked out earlier. And then converting revolutions per minute into miles per hour in number 18 here. Similarly, okay, Alex Spike has a diameter of 28, so it's a radius of 14 inches, and he can pedal 280 revolutions per minute. So 280 revolutions per minute times 60 minutes per an hour. Minutes cancel out, so I've got my per hour. One revolution, right? One revolution is going to give you a distance of the circumference, which is 2 pi r, right? So 2 pi times 14 inches. 12 inches are in a foot, 5,280 feet are in a mile. Punch all that into your calculator and you're going to get 23.324 miles per hour. You'll see that that's the only miles because feet cancels, inches cancel, revolutions cancel, minutes cancel, and hours are the only units left. And then Connor, similarly, the main difference is here, and that was my son coming in. Anyway, Only differences here is 250 revolutions per minute, but he is got larger wheels, right? So the radius is 16, right? 16 inches. Multiply it all out, it's 23.8 miles per hour, right? So even though revolutions per minute, again, is a little smaller because he's on a bigger bike, right? He's actually going a little bit faster. And then the last example, example 19, which didn't get labeled, right? It's our airplane towers, only this time instead of a nice 30, 60, 90 triangle, I'm going to give you a 45, 45, 90 triangle. So, and how do we know that? They are 400 miles apart. Thomas is flying a plane between the towers on a bearing of 315 from the first one, so here's true north. 315 degrees leaves 45 degrees left. So from this horizontal line, there's a 45-degree angle inside here. So he's coming, and he's 45 degrees away from here. And also 45 degrees from the second. So here's my second, 45 degrees from there. So if you have 45 degrees and 45 degrees, and these are going to meet up somewhere, they're going to have to meet up at a 90-degree angle. So again, if you have x, x, the hypotenuse is going to be x rad 2. Again, since by Pythagoras, if you don't remember this relationship of your 45, 45, 90 triangles, you can always use Pythagoras to rederive it, right? Your hypotenuse is going to be x times the square root of 2 for positive x, which you're always going to have in this case. So how far is he from each tower? Well, he's x away from each tower. So if 400 miles is equal to x times rad 2, right, then x is 400 divided by square root of 2, or when I rationalize my denominator, I get 200 rad 2. So he's exactly 200 rad 2 miles, or put it in your calculator, it's about 282.8 miles from each tower, because he's the same distance from each tower in this example. And that is it. Go forth, do homework, and I will see you all Thursday. Quick check on 4.1 on Thursday.